Good morning. My name is Dr. Cameron Jones, and today we are talking about a topic which I love, which is spore traps. And why are these important? Well, I'm a microbiologist and I'm particularly interested in indoor air quality. And this is a petri plate from somebody's main bedroom. And look at all those mold colonies that are formed. But what happens when this might happen to you? What happens when an insurance assessor is sent out to evaluate whether or not the water damage that's happened at your property after a storm or flood water or a broken pipe or some other building breach leads to water damage, and now you've got a foul odor or a smell or visible mold appearing on your personal contents or property? Well, many times you will be presented with data taken from aerosol or spore traps. And I want to talk to you today about the value of spore traps. But how do you actually test them? Well, these aerosols fit onto a biopump, and essentially, in order to measure mold in the air, we're looking at measuring the reproductive part of the mold, which is the spores. And it's a simple matter to use a biopump and connect these aerosols and then move room to room, collecting quantitative data. Now, I want to start at the beginning. Essentially, what are we talking about? Well, we're talking about mold and dampness in people's homes. And I've provided or put together a whole list of references which are going to be provided at the bottom of this presentation in the show notes, and then eventually when this gets reposted out to YouTube. And we're talking about essentially how we measure indoor air quality when there is water damage and dampness in a home, because mold can form not just after a catastrophic event or a plumbing breach. Mold can form in many different situations where you might have fuel poverty or building tightness or a lack of ventilation. And all of these sorts of standards go on about how you actually go about measuring indoor air quality. And I'm going to be talking about a range of different standards which allow you to quantitatively assess your indoor air quality. And I should start at the beginning because before we jump straight into aerosols or petri plates, usually you're going to carry out some form of visual inspection, and there is a standard guide for the assessment of fungal growth in buildings. And this is very important because you don't necessarily need to take quantitative measurements to get a very good overview of what has happened to a building. And so this particular standard is very important to be aware of, especially if you are in the business of doing indoor air quality and mold inspections to assess the impact of water damage. I'm also going to be talking briefly about implementing another standard, which is how you characterize uncertainty in indoor air quality measurements. Way too often I see reports which present the results from aerosols and spore traps with very poor controls, no statistical significance. And again, it's a real shame because these reports then aren't as robust as they should be, and you can't make long-range conclusions based on very poor data. So this particular standard for assessing uncertainty is very important to be aware of. But the most important standard is the standard test method for categorization and quantification of airborne fungal structures in an inertial impaction sample by optical microscopy. And this particular standard is really, 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 really important. And The reason being is it allows you to, in a procedural way, use these aerosols, and this explains what the lab needs to do to provide you with a top-notch A-grade spore trap results report, which in many cases is going to be used to determine scope of works and determine how your building is going to be returned to a normal indoor mold ecology. But before we begin, I want to show you an example of this biopump in action. And in this situation, which again, I just took these samples last week. This is for an insurance job where a new home construction had flooded across the windows that you can see to the left, and the insurers have agreed to replace all the flooring. And when we went in for the initial inspection, all the spore traps for across both levels returned normal indoor air quality results. However, we were perplexed in a sense because that's not really normal. When a building has been water damaged, usually there is evidence in the habitable rooms that there is a problem with your spore counts, which are higher than expected and definitely higher than the outdoor levels. But in this situation, they were normal. So both the insurer and the occupants said we need to work out what's going on behind or inside the walls, because we know that they were flood water affected. And so we can drill a small hole inside the wall and take a spore trap, and immediately we discovered from the living room where that previous photograph was taken that we can see these spores of Stachybotrys. And so this immediately informs the remediator that the insurer will need to make sure that significant remediation occurs. So I've gone over what standards are available, and I've discussed the main one, which is how you actually carry out and measure spore trap data. And I essentially need to discuss a little bit about why these are important. And the key thing is that they're used whenever you need to measure the numbers of spores in the air. And they do allow you to speciate the fungal spores to genus in most cases. And they are very sensitive because the spores are either there or not there. And that's really, really important information, because in many cases there are oftentimes allegations of mold contamination, and yet on quantitative evaluation the rooms might be only slightly affected. And the most important thing about aerosol cassettes and spore traps is that you can create maps of the indoor living environment, and you can work out what the relationship is with the outdoor ratio to the inter-room variability. So I'm now going to show you what these things look like under the microscope, and I'm going to then show you a few videos as well to show them in action. But here is spore trap from a remediator. Just sent these to me a couple of days ago, and I'm hoping that you can sort of see all these small spores here and here. Essentially, if I move the microscope along, you can see all these chains of mold spores, and these are what we measure in the spore trap. And so there's often a lot of other dust and debris. The stain hasn't actually taken up so well, but these are skin flakes, and they're quite commonly observed inside buildings as well. But you can then see, when I make this sharper, these chains of spores, and this is what happens when mold grows inside a building after water damage. But I'm now going to show you a quick little video to highlight the process of collecting spore traps in someone's building.
Good morning, my name's Dr. Cameron Jones and I'm an environmental microbiologist, and the reason I'm making this short little video is to demonstrate one of the reasons why we do spore trap analysis. And behind me you can see that I'm using a biopump. This particular biopump is set at 5 minutes. The reason we do this is that the property behind me has suffered a flood damage, and insurance contractors were brought in a couple of months ago. The family are quite concerned because nothing's happened. They're waiting for a report from some of the insurance appointed experts, but essentially there's only one HEPA air purifier inside this property, and they've got a young family, and the family are quite concerned about mould being a problem, because mould began appearing after the contractors appointed by the insurer brought in their equipment, and so now they're very concerned that the water ingress has led to a mould problem which is not being properly addressed. In any case, I'm using spore traps to measure the indoor air quality, and firstly I need to take some benchmarks for the outdoor controls, so I'm doing that here, and then I'll move room to room and collect spore traps from each of the rooms, including the subfloor and the roof void, to map out the spore concentration throughout this property, and in that way we'll get a very good understanding of whether or not this property is mould contaminated, and if so, where the hotspots or regions of interest are going to be, and then scope of works can be developed which are appropriate for the contamination at this property. Anyway, I'll keep going now. Bye for now.
Okay, from that little video you can see that obviously it's really important to get a measure of your outdoor air, because the outdoor air is used as a reference control, and then you want to also work out what the inter-room variability is inside the home. Now, if I go back to that particular example, this is the property. I was told about that water had flooded essentially the subfloor of this particular property, and these two rear rooms are bedrooms, and the family were particularly concerned about the impact of the odor, because soon after the water ingress occurred under their subfloor, they called their insurer. The insurer came down, assessed the property, and restorers were sent in, who essentially did some preliminary make-safe works. But here they are 4 or 5 months later and nothing's happened. And the smell of mold is reasonably pervasive. So they've gotten us in to measure the indoor air quality because they're concerned about the impact on their family. And the remediators have done a fine job of putting up barrier containment in these rear rooms. But again, as I said, the family are really concerned about the impact of the fact that there's only one HEPA air purifier that's been left at the property. They're wondering when something is going to happen, and there is no data available on the mold spore levels, even though the family have noted that mold has been found growing on items of personal property stored in the rear room. They weren't given any advice on removing their personal property, and again, the adjoining bedrooms used by their young child, and they're very concerned about the potential impact on the health and well-being really of the entire family. So I need to talk about best practices, because in a sense there is a right and a wrong way to do indoor air quality assessments using spore traps. I think it is fundamental that adequate outdoor controls are calculated, which include the mean and standard deviation. And in a sense, this just follows through on the standard for characterizing uncertainty in air quality measurements. You need to use a tripod so that spores are collected from the breathing zone, because the whole point of all this measurement is to assess the impact of the spores and whether or not there is an exposure to people who are breathing. So you tend to put it on a tripod. That means that all samples have been collected in the same way. And you really definitely do need to use more than one method. So you can't just rely on spore traps. So you might need to use Petri plates. You might need to use tape lifts, bio tape lifts, or surface press plates, often called Rodak plates, or assess indoor air quality using a laser particle counter. You could even use ATP if that is a suitable secondary method of assessing surface hygiene. And increasingly, especially with lab reports that I see that have been analyzed overseas, a lot of the data just doesn't make sense. For example, you can have an outdoor control with virtually no mold spores present, which is almost nonsensical from a biologist's perspective. Similarly, you can often find indoor levels which are unbelievably low, and then it just doesn't make sense. So increasingly, I'm wanting to see digital imaging regarding what spores are actually present when you look at these samples under the microscope. And essentially, I'm going to play you another video now because there is another topic. You don't just have to use these in the habitable room volumes. It's really, really, really important, like in the first example, assessing into the wall voids, that you examine for mold in hidden or inaccessible areas of a home. And so if we look at this next video now, you'll see how this is performed.
And I've got the attachment on so that I can do sampling into walls. This sometimes is really important, especially when there's been water ingress and there's concerns about whether or not insulation or plasterboard has become wet on the other side. That is the side that is hidden from view, and it's very important to use spore traps to test the inside walls to guide the remediation effort with regard to strip out works or other forms of remediation.
So I'm also going to play you another little video in a second, because this is something which increasingly is a requirement of the mold assessments that we get called in to do, simply because in many cases there isn't any great evidence of a staining or mold growing through plasterboard, where the impact has been on the underlying framing timbers or the insulation within wall voids or in roof voids. And it's really, really important that spore trap testing does take into consideration those situations where destructive testing is most suitable. And it's really easy to do, but in many cases I see expert witness reports where there are allegations of severe water ingress and contamination, mold contamination on a property, and yet there is absolutely no data for the wall voids or the roof voids. And it's particularly important that you have this. So I will show you an example of how this is done from just last week, at least for me.
In order to do destructive testing, usually I need to make a hole into a wall void, and so I need to make sure that I don't go into any live wires. So I use this to find any electrical points, make sure that I miss them. And that's how you do spore trap testing or destructive testing into walls.
So I hope this presentation this morning has sort of exposed you to the benefits of spore trap testing. I want to end with my 6 tips for success with spore trap testing. I think it's absolutely fundamental that you take enough samples. You must have representative data to answer questions about habitability across the home, and especially in all the regions of interest which are of concern to the occupants. Adequate controls need to be taken. You need to be able to demonstrate statistical significance. Your spore traps need to be taken in the breathing zone. Don't just place the pump on the ground, because there are inlet ports on the back, and that'll be sucking in dirt and debris, which could severely bias the results. Spore trap data should definitely always be linked to other types of sampling. You may need to consider destructive testing, especially where there is a suspicion of hidden mold behind walls. And you should always test the roof void, because that is often a hidden mold reservoir. In any case, I hope today's presentation has been informative and explains some of the benefits of spore trap testing. And make sure that next time you're reading a report about the impact of water damage on your property, that you carefully go through what data has been used to make decisions and develop scope of works for your property. Because at the end of the day, the health and safety of you and your family comes down to whether or not these spores have been firstly detected in all of the hot spots in the home and then have been successfully remediated. And so spore trap testing should be done at the beginning assessment phase, potentially during a remediation, and most definitely as part of post-remediation verification clearance. In any case, I'm happy to answer questions, and I look forward to your comments below. Thanks for watching. Bye for now.